Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numericals based on equivalent weight. All numericals what I am discussing are important for A.I.M.S, IIT, JEE and Neet examination. Now I will continue from the question number 282. Last class I have discussed up to question number 281. Now I am going to start the question number 282. Now I am reading the question. When a metal is burnt, its weight is increased by 24%. The equivalent weight of the metal will be: first option 2, second option 24, third option 33.3, fourth option 76. Questions are little difficult, not more. You can solve it. Keep pen and paper with you so that easily you can solve it. Again I am reading the question. When a metal is burnt, its weight is increased by 24%. The equivalent weight of the metal will be: first option 2, second option 24, third option 33.3, fourth option 76. Just to think. Here first you have to write the chemical equation, then it will be easy for you. Okay, metal, or directly also you can answer. Here metal, you have suppose it is the 100%. Metal that you consider 100 gram. Then oxygen combined 24%. Actually, according to the question, when a metal is burned, its weight is increased by 24%. Suppose metal oxide form, metal plus oxygen, metal oxide will form, their weight is 100 gram. Then its weight increased by 24. It means oxygen is 24 and rest 100 minus 24, 76 is metal. Then after that all things are easy. Equivalent weight is equal to 100 divided by 24, because 24 gram oxygen combined with 100 gram, or its present is 100, is in 100, in 100 gram metal oxide, oxygen is 24 gram, correct? And say 24 gram is present in 100 gram, then 1 gram is present in 100 divided by 24, then 8 gram into 8, and after cancelling you will get 33.3. Metal, question you have to read, then it will clear. When a metal is burnt, its weight is increased by 24%. It means this 24% is oxygen, correct? And 76% is metal. Then 76 plus 24, that is the 100, because question is given in percentage. Then this metal is equal to 100 gram, and oxygen combined, that is the 24. Or you can understand 24% increased. Then suppose if metal was 100 gram, then now it became 124. You can think like that way, it is better. Correct? 24% increased. Means suppose metal was 100, now it became, now 24% increased, now it became 124. You can think like that way. Then 100 gram metal combines with 24 gram oxygen. Very simple way. Because it is given in percentage. Then 24 gram oxygen combines with 100 gram metal. Then for 8 gram oxygen. Then easily you can calculate 24 gram oxygen combines with 100 gram metal. Then for 1 gram, how much? 100 divided by 24. Then for 8 gram into 8, you will get 33.3. Okay. Then correct option is C, 33.3. Third option. It is easy. 24 metal is burned and its weight increased by 24. Then suppose it metal was 100 gram, then now it become 124. Means 24 gram oxygen combined with 100 gram metal. Then for 8 gram, you will get 33.3. Now next question number 283. The specific heat of a metal is 0.11 and its equivalent weight is 18.61. Its exact atomic weight will be: first option 58.2, second option 29.1, third option 55.83, fourth option 27.91. Again one more time question I am reading. The specific heat of a metal is 0.11 and its equivalent weight is 18.61. Its exact atomic weight is: first option 58.2, second option 29.1, third option 55.83, fourth option 27.91. Easily you can calculate. One formula you should know, Petit's law. Okay. Then atomic weight into a specific heat. Dulong and Petit's law, that relation is there. Atomic weight into a specific heat is equal to 6.4 approximately. Then here a specific heat is given 0.11. Then you can calculate atomic weight, approx atomic weight into a specific heat, that is equal to 6.4. By this law, Dulong and Petit's law, you can calculate approx atomic weight. Then approx atomic weight will be 6.4 divided by a specific heat, that is given 0.11. Hence you will get, after cancelling you will get 58.1. Means approx atomic weight you got 58.1. Then you have to find out exact atomic weight. Approx you got 59.1. What is the exact atomic weight? That you have to calculate. For that you required valency. But in question, equivalent weight is given 18.61. Then valency formula also you are knowing, that valency into equivalent weight, that is equal to atomic weight. This formula is very, very important. Valency into equivalent weight, that is equal to atomic weight. Then valency is equal to atomic weight divided by equivalent weight, approx atomic weight. Then approx atomic weight you calculated 59.1 divided by equivalent weight. Equivalent weight is given 18.61. Then 58.1 divided by 18.61, you got valency 3. Then now exact atomic weight is equal to what? Same formula you have to use, because now you are knowing the valency and approx valency and equivalent weight already given. Here equivalent weight 2 times you have used. First same formula 2 times you are using. Correct? Valency into equivalent weight, that is equal to atomic weight. This formula 2 times you are using. First time in calculating the valency, now you got 3, because atomic weight, valency is equal to atomic weight divided by equivalent weight, means 58.1 divided by 18.61. You will get 3, approx 3 you will get. Correct? Valency 3 you got. Now exact atomic weight, same formula. Valency into approx atomic weight. So now you are getting, you have calculated valency. Even you are getting suppose 2.999, that is you can write only 3. More 0.5, that will increase by 1. If suppose more than 0.5, suppose 2.6, 2.7, then you can write 3 only. And if it is less than 0.5, then suppose 2.4, 2.3, they write only 2, whole number. Then here exact atomic weight will be 3 into 18.61, that is equal to 55.83. Exact atomic weight will be valency into approx atomic weight, then 3 into 18.61, that is equal to 55.83. Correct answer is 55.83, and say option C is correct. Option C is correct, 55.83. This question was asked in AMU. Now next question I am discussing the vapor density of a volatile chloride. Volatile chloride. The vapor density of a volatile chloride of a metal is 95%, 95, not percentage, 95, and the specific heat of the metal is 0.13. The equivalent weight of the metal will be approximately, first option is 6, second option is 12, third option is 18, fourth option is 24. Again I am reading the question. The vapor density of a volatile chloride of a metal is 95, and a specific heat of the metal is 0.13. The equivalent weight of the metal will be approximately, first option 6, second option 12, third option 18, fourth option 24. Just to think, in your mind you think which formula will be used, at least you think, then after that you can do. Means what technique will be applied, what formula will be applied, just at least to think in a short time, only then you can solve it. Then now just to think, I think you can solve it. Vapor density is given 95, correct? Then approx atomic weight, these things, what is given? Vapor density is 95. Then now here vapor density is 95. Then molecular weight of volatile metal chloride. The metal chloride means you don't know which type of chloride is there. Maybe MCl, maybe MCl2, maybe MCl3. You don't know. Means you have to know the valency. Correct? Only then you can calculate the molecular weight. Because vapor density into 2, that is equal to molecular mass, you know. Then valency first you have to calculate. Then first to calculate approx atomic weight, because this is given, a specific heat is given. Whenever a specific heat is given, it means DeLong and Petit's law you have to apply. Then their approx atomic weight will calculate 6.4 divided by 0.13, because a specific heat is 0.13. Then approx atomic weight into a specific heat is equal to 6.4. Then approx atomic weight will be 6.4 divided by 0.13. It is given a specific heat. Then you got the atomic weight 49. After solving, you will get 49. Then now molecular weight you can calculate, but you will not calculate exact, because chloride, which type of chloride is there, MCl, MCl2, MCl3, that you don't know, but it is the, you can say, chloride of a metal. Then MClX you consider, X value you have to find out, MClX. Then what is the molecular weight of MClX, where X is the valency? Atomic weight, this approx atomic weight already you calculated, 49. Then if you will know the valency, then your problem will be solved. Then molecular weight, by the calculation of molecular weight of this metal chloride, you can get the value of X. Suppose molecular weight of MClX, X you have to calculate, will be what? That is the molecular weight, you know, that is the 2 into vapor density. 2 into vapor density is equal to molecular weight. Correct? Means 2 into 95. Means 2 into 95 means 190. 190. Then that molecular mass you are knowing. But X value you have to calculate, MClX. MClX is equal to 190. Correct? 2 into vapor density is equal to molecular weight. In the beginning I told you. Then MClX is equal to 190. But what is the value of X? Then that you can write MClX. Now you can bifurcate. You can write like this: atomic weight of M. M means metal, plus X into 35.5, that is equal to 190. Correct? Now easily you can calculate the X value. Atomic weight of M plus X into 35.5, that is equal to 190. Then atomic weight already you calculated in the beginning, 49. 6.4 divided by 0.13. A specific heat is given. Then 49 you got atomic weight of M, and X you have to calculate into 35.5, that is equal to 190. Then all things you are knowing, only X you are not knowing. Then X easily you can calculate. That is the 35.5 into X is equal to 190 minus 49. Take this 49 to the right side, minus 49. 190 minus 49. Then now X is equal to, easily can calculate 190 minus 49 divided by 35.5. After solving, you will get 141 divided by 35.5, that is roughly 4. 4 means X is equal to 4. Then now valency you are knowing. Then same formula you can use. Equivalent weight into X is equal to M. M. Okay. Then now here X value is 4. And equivalent weight into valence is called molecular mass. Don't forget. Valency into equivalent weight, that is equal to atomic mass. Correct? And this molecular mass. Equivalent weight into valency is equal to molecular mass. Then now easily you can get the value. That is the X into E plus 35.5. X into equivalent weight, the equivalent weight, how will get this E 190 you calculated, 190 you calculated, that is how you get atomic weight plus x into 35.5, that is equal to 190. And now you got the value of x is equal to 4. Then now you can get the this E value easily. You can get x into, in bracket you write E plus 35.5, that is equal to 190. Then what is the value of E? E is equal to 190 divided by 4. Or directly you can use the formula. Or you can put the value of x simply. You will get x into, in bracket E plus 35.5, that is equal to 190. Then simply you just to calculate the this E value, because x value you are knowing 4. Then 190 this x into, in bracket E plus 35.5 is equal to 190. Then E plus 35.5 is equal to 190 divided by x. Here x is equal to 4. So that is equal to E plus 35.5. Then after solving you will get 12. Okay, E is equal to, you will get 12, means 190 divided by 4 minus 35.5. Just so simply you have simplified. X into, in bracket x is common, in bracket E plus 35.5, that is equal to 190. Then E is equal to, easily you can calculate E plus 35.5, that is equal to 190 by 4. Correct? Then E is equal to 190 divided by 4 minus 35.5. Take left this 35.5 from the left side to the right, means 190 minus 35.5. You will get 12. Hence you got the value of equivalent weight. Okay, you got the this equivalent weight you got. Then now equivalent weight you got 12. Equivalent weight you got 12. But you have to calculate exact atomic weight. Then now when equivalent weight you are knowing, then equivalent weight into valency is equal to exact atomic weight. Correct? You have calculated two things. First you calculated valency, and after that you calculated equivalent mass. Two things you have calculated. Then equivalent mass into valency, that is equal to exact atomic weight. Then now just equivalent weight is 12. The 12 into 12 we got is equal to 12. Okay, equivalent mass 12. Then 12 into 4. 12 into 4. Distance. Then 12 into, no, you have to calculate equivalent weight only you have to calculate. Then equivalent weight already calculated 12, not the atomic weight. Equivalent weight you have to calculate. Then equivalent weight already calculated 12. Hence option B is correct. Option B is correct. Atomic weight you have not calculated. Vapor density, in question vapor density of metal is given 95. Correct? And specific heat is given 13. Then with the help of Dulong and Petit's law, you can get the value of approx atomic weight, means 95 divided by 0.13. You will get these things 49. Approx atomic weight you will get 49. With the help of this atomic weight, approx atomic weight, you can get the value of x, means valency. Correct? That is the 4. You got the 4. Because atomic weight, you can bifurcate MCLX. M is 49 MCLX, then plus X into 35.5, and that is equal to 190. 190, how did it come? Then it is given vapor density, the vapor density into 2, that is the 95 into 2, 190. Then easily you can calculate the value of X value, easily you can calculate, that is the valency. Now valency you are knowing. Then after that, by the use of the formula, equivalent weight into valency, that is equal to molecular mass, M you can tell. Then now just E means now 4 you are knowing, then just simply you put the value of 4 in the above equation, correct? Atomic weight of M you are knowing, X we are not knowing. Now X also you are knowing. X you are knowing. Then X you are knowing, then just simple formula is there. M is equal to E into X. Correct? Then that E M is equal to, you are knowing, 190 M. X is 4. Then E is easily you can calculate. Correct? Then you can calculate very easily E 190 divided by 4. 190 divided by 4 minus 35.5, because here that 190 is you calculated, that is the 2 into vapor density, 190, and that is equal to E X into E, or X is common inside bracket, E plus 35.5 is there. Then only E you are not knowing, X you are knowing now. Okay, this formula is very, very important. Now molecular weight is equal to E into valency, correct? Then now molecular mass is equal to 190, and in the place of E, now you can write E plus 35.5, because it is a metal chloride, metal plus chloride, chlorine 35.5. Here only things are important. Here E you are writing for metal chloride, not only for metal chloride. Then for E, because X already outside you have written, then E plus 35.5. Then X you are knowing, E you are not knowing, plus 35.5. Correct? In bracket E plus 35.5 is there. Metal chloride I am talking about, not only metal. Metal chloride means E plus 35.5, and outside X is there, valency. Then valency is equal to 4. Valency is equal to 4 and total is equal to 190. Then E easily you can calculate. E is equal to 190 divided by 4 minus 35.5, that is equal to 12. Then now you got the value of these things, equivalent weight. Equivalent weight you got 12. That is option B is correct. Actually this question was little long, but this type of question is asked. Okay. Here only all relation you should know, that vapor density into 2 is equal to molecular mass. One formula you have utilized. Second formula you have utilized, that this thing, atomic molecular mass you can bifurcate, atomic MCLX. Then you can write atomic weight of M plus X into Cl. X into Cl, that is the molecular mass, that is given 190. Then second formula you have utilized this. Okay. then atomic weight of M you just calculated already by the Dulong and Petit's law, correct? Then with the help of this you got the value of X. Then two formula you have utilized, and third formula you have used here, that is the molecular mass is equal to equivalent mass into valency. But here equivalent mass you are using for metal chloride. That's why in the place of E you are writing E plus 35.5. Correct? X you have to write. It is not only for metal, it is for metal chloride. That's why E plus 35.5 into X is equal to 190. Then you have E value means equivalent weight you calculated. For metal you calculated. Okay. Now we are calculating this is E of metal. E of metal. That is the 12. 190 minus divided by 4 minus 35.5. 12. Okay. You have not calculated equivalent weight of metal chloride, only for metal. Then this is actually important things. A student will get confused in calculating this molecular weight of chloride, metal chloride. No, you have calculated equivalent weight of metal. That's why in the place of E you have written E plus 35.5. Formula is the same, X into E formula, but here E is equal to E plus 35.5. That is equal to 190, and you calculated the E value. That is the equivalent weight of metal, 12. Option B is correct. So this three formula used means it will be not asked in this ordinary competition. It is for advance only. IIT advance, this is the fittest question. It is 3 for generally maximum 2 formula it is applied. But here 3 formula you have applied. Then it became 3, little difficult. Then it is fit for IIT advance. Sometimes in A.I.M.S also it can be asked. Neet generally they will ask little easy. Not they will ask mediocre means not very tough. Tough they can ask, not very tough. Next question. Question number 285. 0.84 gram of carbonate of a metal M gave on heating 0.40 gram metal oxide. The specific heat of metal is 0.25. The atomic weight of the metal would be, first option is 12, second option is 24, third option 36, fourth option 48. One more time question I am reading. 0.84 gram of carbonate of a metal M gave on heating 0.40 gram metal oxide. The specific heat of the metal is 0.25. The atomic weight of the metal would be, first option 12, second option 24, third option 36, fourth option 48. This you have to think. You can this also at least two formula you think which formula can be used, how many formula can be used. Try to understand the question, then only you can solve it. And thinking will take hardly, first is in your mind it should come, okay, this step you have to take at least. After that you can solve. Then at least you think how it will be solved. Here it is a metal carbonate, 0.84 gram, metal carbonate, and on heating you got metal oxide. This you have to think. Only then you can solve it. And a specific heat of the metal is given 0.25. Means Petit's law, Dulong and Petit's law you have to apply. Then When a specific it is given, the approx atomic weight you will calculate first. Correct? After that, you have to calculate the exact atomic weight. Exact atomic weight. The atomic weight of the metal will be 12, first option, second 24, third 36, fourth 48. Then approx you are calculating. At exact you have to tell. For that purpose, these data are given. Now you think. Now see here, one formula is there. Already I have discussed this type of formula. For this, when two types of product will be there, metal carbonate and metal oxide, then that time this type of formula you can utilize. I am telling you, weight of metal carbonate and metal oxide both are given. In that situation, you have to use this formula. Weight of metal carbonate divided by weight of metal oxide is equal to, now break into two parts. For weight of metal carbonate, you can write equivalent weight of metal plus equivalent weight of carbonate divided by now equivalent weight of metal oxide. Same things you can write. Weight you are writing in terms of equivalent weight. Then weight of metal oxide means equivalent weight of metal plus equivalent weight of oxygen. Okay, or oxide you can tell. You have weight you are writing in terms of equivalent weight. You have divided in two parts. Weight of metal carbonate, now you are writing in terms of equivalent weight. Then weight of metal carbonate divided by weight of metal or oxide, that is equal to equivalent weight of metal plus equivalent weight of carbonate. Similarly, down you can write divided by equivalent weight of metal plus equivalent weight of oxide, O2 minus. Oxygen 2 minus will be there. Then after that, weight of metal oxide is given 0.84 and weight of metal carbonate is given 0.84 and weight of metal oxide is 0.40. That is equal to E value you have to calculate first. You don't know equivalent weight of metal, you write E plus 30. Why 30? Then carbonate CO3 you calculate molecular mass. 12 plus 48, 60. 60 divided by 2, because carbonate means 2 minus. Number of electron is 2. The per electron you have to calculate weight per electron. That is the equivalent weight. This also you keep in mind. Two negative charges there. Then you have to divide by 2. Then 60 divided by 2, 30. Then equivalent weight you don't know, then you can write equivalent weight of metal E. Capital E you can write plus 30. Now divided by same way equivalent weight of metal, already you are knowing only E, you have to write it down also, E plus equivalent weight of oxygen. Then here O is there. Then 16 divided by 2, atomic weight of oxygen is 16 and here 2 negative charges there, O2 minus, because it is metal oxide. Then O2 minus, then divided by 16 divided by 2, that is the 8. Then now you got the relation 0.84 divided by 0.40 is equal to E plus 30 divided by E plus 8. Then all are you know only except E, all things you are knowing. Up is also E, down is also E. Correct? In denominator, numerator, both E is there. Hence after cross multiplication, you can get the value of E. Then E value after cross multiplication, if you will solve, then E value will get 12. 12 is the equivalent weight of the metal. You have to calculate atomic weight of the metal. Then approx atomic weight. You require actually atomic weight. Then Dulong and Petit's law you have to apply here, because 0.25 it is given. Correct? 0.25 specific it is given, then approx atomic weight will be 6.4 divided by 0.25 means 25.2. Now you are knowing the atomic weight. Now you are knowing 25.2, and this you are knowing equivalent weight also you have calculated. Then how atomic weight and equivalent weight are related? Just you remember the formula, that is this equivalent weight into valency. Here first to calculate valency because now approx atomic weight you are knowing. Approx atomic weight you are knowing 25.2 and equivalent weight is 12. Then valency is equal to what? 25.2 divided by 12 means approx atomic weight divided by equivalent weight, because formula valency into equivalent weight is equal to atomic weight. Then by use of this formula, valency you can calculate 25.2 divided by 12. Valency into equivalent weight, that is equal to what? Equivalent weight. Correct? Equivalent weight is given 12. Then valency is equal to, you got now 25.2 divided by 12, 2. Okay, this formula is very, very useful. Valency into equivalent weight, that is the approximate atomic weight. This is the formula. In the case of metal, you can utilize this formula. Valency into equivalent weight, that is equal to atomic weight. Then now valency you calculated 25.2 divided by 12, both you are knowing, you have calculated. Then 25.2 divided by 12, roughly it will come 2. Okay, 2. Then now valency you are knowing 2 because you have used approx atomic weight. 25.2 was approx atomic weight, but you wanted to know exact atomic weight. Then again you have to use the same formula. Then exact atomic weight will be what? Now exact atomic weight will be valency you have calculated, that is the correct 12. Now you calculate this equivalent weight exact 12 you are knowing. Now valency you calculated. From the approx atomic weight you calculated valency 2, that is equal to 2, 25.2 divided by 12, roughly 2. Hence now by using the same formula, 2 times you are using the same formula. Exact atomic weight is equal to 12 into 2. Here what is the 12? 12 is equivalent mass. Equivalent mass into valency, that is the exact atomic weight. Correct? With the help of approx atomic weight you calculated valency. Correct? Now for exact atomic, to calculate exact atomic weight, you have to use the same formula, that is the equivalent weight into valency, means 12 into 2, that is equal to 24. Hence correct option will be B, option B, 24. Okay, this question is also little difficult because here also 2-3 formula you are using. 2-3 formula is required to solve. Same formula 2 times you have utilized. Deuling and Petit's law you have utilized. Correct? Then this question is coming under the tough, not very tough. Now next question, one more question I want to discuss, that is question number 286. 286. In alkaline medium, KMnO4 reacts as follows. 2KMnO4 plus 2KOH. Products are given 2K2MnO4 plus H2O plus O. Therefore, the equivalent weight of KMnO4 will be first option 31.6, second option 52.7, third option 7.0, fourth option 158. One more time, I am reading the question. In alkaline medium, KMnO4 reacts as follow. Reaction is given 2KMnO4 plus 2KOH. Products are given 2K2MnO4 plus H2O plus O. Therefore, the equivalent weight of KMnO4 will be first option 31.6, second option 52.7, third option 7, fourth option 158. Just you think, here you have to give consideration for the given reaction. Here, what is the main things? 2KMnO4 is giving one oxygen, nascent oxygen, only one O. 2KMnO4 is equivalent to one oxygen, nascent oxygen. Then one oxygen means 16 parts. Correct? Atomic weight of oxygen is 16. Then 2KMnO4 means 158. You know, KMnO4 atomic KMnO4 molecular mass is 158. Correct? Then here 2 into 158. That is giving 2 molecule of KMnO4 is giving 1 atom of oxygen, means 16 parts. Then 2 into 158 gram is equivalent to 16 parts of oxygen. Then for 8 parts, how much KMnO4 is required? Then only 158. For 16 part is given by 2 into 158 gram KMnO4. Then only 8 parts, 50%, means only 158 part of KMnO4. For one oxygen atom, how much weight is required? That is actually equivalent weight per oxygen atom. Then for the 16 part, means for 2 part, you require 2 into 158. Then for 1 part, only 158. 16 part, other way, 16 part, you are getting by 2 into 158. Then 8 part, then half of this, 2 into 158 divided by 2 means 158. Hence equivalent weight will be 158. Option D is correct. This question was asked in 2 exams, NCERT also and medical also, CPMT. Okay. Then this question is medium level. Okay, not too much formula is used, only one formula you have just applied here by seeing chemical equation, only chemical reaction, by seeing the chemical reaction and knowing that 8 parts of oxygen will react with how much part of KMnO4. This concept only. This question was asked in medical and NCERT also. Now I am stopping only here. Next class again I will continue. Thank you.